Welcome to our video lesson on the core concepts in secure software development. In this session, we will cover crucial aspects like confidentiality, integrity, availability, authentication, authorization, accountability, and non-repudiation. These concepts form the foundation of developing secure software, and understanding them is essential for any software development team. Section 1. Core security concepts. Confidentiality. Confidentiality is about preventing unauthorized disclosure of information. The goal is to keep secrets secret. To achieve confidentiality, we use techniques like access controls and encryption, depending on whether the data is at rest, in transit, or in use. Key elements to determine include who is authorized to see specific data elements, mechanisms to enforce confidentiality, business requirements for data collection, transfer, storage, and use. Implementation. Encryption is the primary method used to protect data from unauthorized observation. It requires an algorithm and a key. The failure of cryptographic protections often results from using non-approved algorithms or failing to protect the key. It is crucial to employ best practices, such as using approved cryptographic libraries and securing the keys. Integrity. Integrity refers to protecting data from unauthorized alteration. This is more fine-grained than just access control. It involves ensuring that users can view information, but not alter it unless authorized. Key elements to determine include who is authorized to alter specific data elements, mechanisms to detect errors and enforce integrity, business requirements for data collection, transfer, storage, and use. Implementation. Integrity is often ensured through access control mechanisms and cryptographic hashing. Hash functions can verify that data has not been altered by comparing current and original hash values. Digital signatures and code signing can also ensure that data remains unchanged. Availability. Availability ensures that systems are accessible to authorized users when needed and inaccessible to unauthorized users. This involves determining the criticality of data and ensuring the system's availability matches its importance. Common availability issues include denying illegitimate access and preventing denial of service attacks. Implementation. Designing systems with appropriate levels of availability involves balancing resources among confidentiality, integrity, and availability requirements. Section 2. Authentication and authorization. Authentication. Authentication is the process of verifying the identity of a user. This is fundamental for security, as it differentiates between authorized and unauthorized users. Authentication methods include something you know, for example, passwords, something you have, for example, tokens, something you are, for example, biometrics. Multi-factor authentication. Combining two or more methods enhances security. For example, using a card reader that activates a fingerprint scanner. Identity management involves the comprehensive set of services related to managing digital identities. It includes provisioning, management, and deprovisioning of identities. The identity lifecycle must be managed securely and efficiently. Identity provider IDP. An IDP creates, maintains, and manages identity information. Standards like SAML, OpenID, and OAuth are used for identity management. Identity attributes. These are specific characteristics of an identity, such as name, department, location, login ID, and email address. Understanding these attributes is essential for managing identities in systems. Certificates. Certificates, such as X509, are used for proving identity via digital signatures. They bind an individual's identity to a public key, ensuring authenticity. Identity tokens. Tokens represent claims about the authentication of an entity. They are used for access control and can include smart cards and keys. Authorization. After authentication, authorization determines what actions a user can perform. It involves applying access control rules to user processes. Key elements include the subject authenticated user, the object resource being accessed, the type or level of access granted, Access control models. Various models, such as mandatory access control MAC, discretionary access control DAC, role-based access control RBAC, and rule-based access control are used to manage these permissions. Section 3. Accountability and non-repudiation. Accountability. Accountability involves recording actions and the users performing them. This is crucial for auditing and ensuring that activities align with security policies. Audit logs should be created to track critical transactions, providing a historical record that can be reviewed later. Logging. Effective logging requires determining what information needs to be logged and where it should be stored. This helps in incident response and compliance with various standards. Tools like syslog are used for managing log messages. Non-repudiation. Non-repudiation ensures that a user cannot deny performing an action. This requires robust authentication, authorization, and auditing systems to log actions accurately and prevent repudiation claims. Conclusion: understanding and implementing these core concepts, confidentiality, integrity, availability, authentication, authorization, accountability, and non-repudiation, is essential for developing secure software. By following best practices and employing the right techniques, software development teams can ensure their applications are secure and trustworthy. Thank you for watching this video lesson on the core concepts in secure software development. Stay tuned for more in-depth discussions on each topic in our upcoming videos.